What would it mean to find another Earth? Just think about that for a moment. Not just a planet, but another world. A twin to our own blue marble spinning around a distant star, a place with oceans, continents, and maybe, just maybe, an atmosphere that breathes like ours. This question isn't just science fiction anymore. It is one of the most profound questions we can ask. It drives us to build bigger telescopes. It pushes us to look deeper into the cosmos. Finding a second Earth would change everything we think we know about our place in the universe. It would tell us that the conditions for life, for us, might not be so unique after all. The universe is vast, unimaginably vast. And in all that space, are we truly alone? The search for Earth's twin is a search for an answer. It's a quest to find a pale blue dot just like our own. This isn't just about finding alien life. It's about understanding the very processes that created our world. And as we search for other worlds, something strange has happened. The universe has started sending messengers to us. Not little green men in flying saucers, but cosmic travelers, objects thrown out of their own star systems, wandering the galaxy for millions of years. Now, they are passing through our own cosmic backyard, and they might be carrying secrets. Secrets about the star systems they came from. So how do we even find these cosmic travelers? It's not easy. They're typically small, they're typically dark, and they're moving incredibly fast. It's like trying to spot a speeding bullet in the dead of night. The key is to watch the sky. Constantly. We have powerful survey telescopes that scan the entire sky, night after night. They take pictures of millions of stars, and look for anything that moves. Most of the things that move are our local asteroids and comets. They follow predictable elliptical orbits around our sun. We've been charting them for decades. But an interstellar object is different. It doesn't play by our solar system's rules. When we plot its path, we find something extraordinary. It's not a closed loop. Think of it this way. Objects from our solar system are on a leash, tied to the sun's gravity. An interstellar object just cuts through. It comes in from one direction, whips around the sun, then shoots off in a completely different direction, fast enough to escape the sun forever. This is how we found Oumuamua. An observatory in Hawaii spotted a faint dot of light moving at a blistering pace. When they calculated its orbit, it was clear this thing was not from around here. The discovery required quick thinking and a global effort. The process is a race against time. As it moves away from the sun and the earth, it gets fainter and fainter until our telescopes can no longer see it. So, let's talk about our first two confirmed interstellar guests, Oumuamua and Borisov. They were honestly as different as night and day, and each one told us a unique story. Oumuamua, whose name is Hawaiian for a messenger from afar, arriving first was a true enigma. Discovered in 2017, maybe just a few hundred meters long and incredibly faint. But the most baffling thing was its behavior. Then in 2019 along came 2I/Borisov, discovered by amateur astronomer Gennady Borisov. This visitor looked much more familiar. It behaved like a classic comet. We studied its composition in detail, and it wasn't so different from our comets. Borisov felt reassuring. It suggested comets across the galaxy might be similar. From just two visitors we learned two big things. First, Borisov hinted that the icy building blocks of planets may be common. That's promising for the possibility of life, since comets likely delivered water and organic molecules to early Earth. And now, here in 2025, we have a third visitor. Let's call it C2025F3, or just F3 for short, just for fun. Early observations show that it has properties that seem to fall somewhere between the bizarre Oumuamua and the familiar Borisov. But a third object starts to fill in the picture. It's a new data point, a new clue in our cosmic detective story. Our ability to find and study these fleeting visitors depends entirely on our telescopes. They are, well, our eyes on the cosmos, and our eyes are getting bigger and better all the time. The Hubble Space Telescope, orbiting above Earth's blurry atmosphere, has been invaluable. It can see incredibly faint objects with stunning clarity. The Vera C. Rubin Observatory, currently nearing completion in Chile, is poised to revolutionize this search. This observatory is, honestly, a beast. It has a huge mirror and a massive camera, the largest digital camera ever built. Its job is to survey the entire visible sky every few nights. It will produce a colossal movie of the universe, cataloging billions of stars and galaxies, and most importantly for us, billions of moving objects within our solar system. The Vera Rubin Observatory will be the ultimate net for catching interstellar objects. Its sheer speed and sensitivity mean that instead of finding one of these visitors every couple of years, we might start finding several every year. Telescopes like the James Webb Space Telescope, JWST, are perfect for characterizing them. JWST is designed to see in infrared light, which is ideal for studying the composition of cold, dark objects. The search for exoplanets has exploded in the last 2 decades. We've found thousands. How do you find a tiny, dark planet next to a huge, bright star? It's like spotting a firefly next to a searchlight from miles away. The transit method is watching for shadows. That causes a tiny dip in the star's brightness. NASA's Kepler used this method with massive success. We analyze starlight that passes through the atmosphere during transit. Gases absorb specific colors, leaving a chemical fingerprint. Look for signatures of water, methane, oxygen, and other gases that could indicate a habitable world, or even life. So, what are we looking for when we talk about an Earth twin? It's more than just finding a rocky planet. First and foremost is size. The planet needs to orbit its star in the habitable zone, sometimes called the Goldilocks zone. This is the region around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist on the planet's surface. Then there's the atmosphere. It needs to be thick enough to protect the surface from harmful radiation, but it can't be too thick, or you get a runaway greenhouse effect like on Venus, where the surface temperature can melt lead. The composition is also key. The presence of oxygen would be a blockbuster discovery, as oxygen on Earth is primarily produced by life. Now let's connect these two grand quests. Could these interstellar objects be more than just random rocks? Could they be messages in a cosmic bottle carrying vital clues about the very worlds we are trying to find? Every interstellar object is a physical sample from another solar system, a piece of a distant puzzle delivered right to our doorstep. Imagine we find an interstellar object that is rich in certain organic molecules, the building blocks of life. If we can trace its path back to its parent star, and then we discover a rocky planet in that star's habitable zone, we've just connected 2 huge dots. It would suggest that the raw materials for life were present in the same system that hosts a potentially habitable world. What if we find an interstellar object that looks like a fragment of a larger, differentiated body? This would tell us that planet-forming processes elsewhere can create complex, rocky bodies similar to those in our own solar system. If a large asteroid impacted a planet with life, it could have blasted fragments of that planet's crust into space with enough velocity to escape their star system. If one of those fragments, a piece of an alien world, journeyed through the galaxy and passed through our solar system, what could we learn from it? We could analyze it for biosignatures, chemical traces that could only be produced by life. It's a long shot, but the universe is a big place and time is long. So why does any of this matter? Why do we spend billions on telescopes? Why countless hours staring into the void? Because it speaks to something deep within us. A fundamental curiosity about our origins and about our place in the cosmos. Are we a fluke? A lucky accident in a barren universe? Or is the universe teeming with worlds like ours, and perhaps even life? These discoveries push the boundaries of science and technology. Medicine, communications, computing. The quest to explore makes us smarter and more capable on Earth. Looking up gives us perspective. Our problems can seem smaller. We are all crew members on a tiny, fragile spaceship called Earth, hurtling through the cosmos. Our divisions seem insignificant against the universe's scale. Searching for another Earth helps us understand and appreciate our own. It highlights the precious conditions that make life possible here. In the end, we look up because it's in our nature to explore, to question, to seek knowledge. We are the universe made conscious, trying to understand itself. Every exoplanet we discover, every interstellar object we study. The search continues. The universe is waiting, and we are looking. Keep looking up.